Good day, students, and welcome to your online version of the Jet Forces lab. In this video, we'll go through the lab guide. We'll have a look at the equipment we're going to use and the method or the procedure and how we capture the data and what is expected of you for this online lab. So in the next section, let's have a look at the lab guide. Right, here's the lab guide. That's the impact of jet forces. Then you have your table of contents. First section is the aim of the experiment, and is to measure the forces exerted by jet on different deflectors and then compare them. Section 2 is what you need to do, and then section 3 is the theoretical background of jet forces. And in important section over here is the given data, which you'll need to finish this lab. Next section is the experimental apparatus. That's the apparatus we'll be using for the experiment, and I'll more about this once we go into the lab. Then we have the procedure. The procedure I will cover in a later video, and the results. Just a note on the results. There is asking for theoretical force versus the flow rate. And just remember to plot both deflectors' results onto one graph so it's comparable, and the same for the measured force. There is a note about it at the end of it. Then in the appendix A is the tables of the raw data, the data we'll be capturing. Again, we'll be using the float height on the hydraulic workbench. We're going to measure how long it takes to fill 5 liters of water, the time, and we're going to record the jockey distance, and the rest needs to be calculated by the student. Just have a read through at the bottom to make sure what's going on in the raw data. And the raw data you will also receive via the online platform, either in an Excel spreadsheet. The equipment we're going to use for this experiment, again, we're going to make use of the hydraulic workbench with the rotometer over here. There's the stop and start. And then we have the side class over here, which we use to measure the actual flow through the system. You can refer back to the video of the rotometer lab for all the details about how the hydraulic workbench works. Then we attach the jet force apparatus to the workbench. Here is the inlet, and that of course is the jet. Then over here we have a flat plate. We're going to measure the jet force on a flat plate and on a hemispherical plate, which I will show a bit later. And then on top we have the jockey, we have the adjustment screw, we have the pivot point, and then this ruler over here would be the jockey distance. On the apparatus there's a sticker with some constants: the jockey mass 600 grams, the nozzle diameter is 10 mil, and the vane pivot center is 150. That 150 is from the pivot point to where the 0 is. And then lastly is the vane above the nozzle, that's 35 millimeters. So from the nozzle to the plate is 35 millimeters. That's the apparatus we're going to make use of. And the next section, we're going to go through the method or the procedure on how to capture the data. We're going to do this experiment for a flat plate, which is currently installed, and then also on a hemispherical plate. And the method or procedure for the flat plate and hemispherical plate is exactly the same. The only difference between the two plates, the water deflection on a flat plate is 90 degrees, and on a hemispherical plate it will be 180 degrees. Before we start capturing the data, we want to make sure that our balance arm is in equilibrium. So what we do is we put our jockey mass on 0. We use that little stripe and we put it on 0. And then we want to make sure that this tully, which has 2 notches, aligns with the top and bottom of the flange. And we use the adjusting screw to adjust. Right, so now when the jockey is on 0, my balance arm is horizontal. As soon as we add a force on the plate, the pivot arm will lift, and then we move the jockey to push the arm down to our original reference point. We're going to do this for increments. On the rotometer, we're going to start at 0 and then jump increments of 20 millimeter. And then for each increment, we need to move our jockey so that our balance arm is back to our original reference point. So my rotometer is now set on 0, and you can see that my balance arm lifted a little bit. So I have to move my jockey slightly so that I'm back to my original reference point. And then I'm going to record my jockey distance. It's a bit not focused, but it's about 3 millimeters. So I'm going to record my jockey distance, which is 3 millimeters, and then again we're going to measure the actual flow going through the system at this moment by measuring how long it takes to fill 5 liters of water. So that will be from one marking to the next. That's 5 liters of water. So let's record how long that took. So for my next data point, I'm going to set my jockey on 20, and then you can see again my balance arm lifted a little bit, so I move my jockey slightly so that I'm back to my original reference point. And now the jockey distance is sitting at 7 millimeters. And again, we're going to measure how much flow is going through the system. We continue doing this. I'm just going to put it on a higher rate so you can see the effect of it. So there you can see my balance arm lifted quite a lot. And if I move my jockey now, so I'm back to my reference point, you can see the jockey distance is over 30 millimeters. I've attached the hemispherical plate, and you can see that the water deflection on the hemispherical plate is 180 degrees. There we go. You can see there's 180 degrees. The procedure for the hemispherical plate is exactly the same as the flat plate. We're going to set our rotometer on increments, and for each increment we'll measure the jockey distance and the flow going through the system. This video covered the lab guide, the equipment we're going to use, and also the method or procedure on capturing the raw data. If you have any questions about the hydraulic workbench, please go back and watch the video for your rotometer calibration lab, which explains in detail how the workbench works. And the method or procedure to capture the data for the flat or the hemispherical plate is exactly the same, by putting the rotometer on certain increments and measuring the jockey distance and the actual flow rate going through the system. You will receive the lab guide, the video, and the raw data via the online platform, and then you have to do a multiple question on Blackboard.